Hello, my name is John Wells and I'm an Associate Professor in the Integrative STEM Education Graduate Program at Virginia Tech. Presented in this short narration is the meaning of Integrative STEM Education as defined by the program of the same name. As a preface to explaining the meaning, it is important to recognize the long-established role of integration in our national standards. Technology and engineering education is the only discipline whose standards were conceived of and designed to teach STEM content and practices as an integrative endeavor. Technology and engineering education represents the T&E in the STEM education acronym, and our standards for technological literacy are explicit in envisioning the study of technology as, quote, a way to apply and integrate knowledge from many other subject areas, not just mathematics, science, and computer classes, but also the liberal and fine arts, end quote. Technology and engineering education is not STEM, nor is it STEM education in general. The pedagogical role of technology and engineering education is as an integrator of knowledge, and our unique contribution within the broader context of STEM education reform is through integrative STEM education. Integrative STEM education provides the conceptual framework necessary for implementation of that pedagogy, and the essence of that framework is captured in the Virginia Tech operational definition, which is the application of technological and engineering design-based pedagogical approaches to intentionally teach content and practices of science and mathematics education through the content and practices of technological and engineering design education. Integrative STEM education is equally applicable at the natural intersections of learning within the continuum of content areas, educational environments, and academic levels. The definition is clarified through explanation of the various elements. Within the title itself, the term integrative implies an ongoing, dynamic, learner-centered process of teaching and learning. This is distinctly different from integrated, which connotes a static, completed, teacher-centered process. The leading pedagogical concept is technological and engineering design-based learning, which is presented as the instructional requirement for any integrative STEM education lesson. That concept is immediately followed by intentionally, which is italicized to emphasize its importance and refers to the design of instruction intent on targeting the teaching and learning of selected STEM content and practices, not only those of technology and engineering, but science and mathematics as well. The intent to teach is paramount and implies assessment of learning as a required component of the instructional design. It is central to the concept of integrative STEM education and is what distinguishes it from all other models. The last sentence of the definition is significant in that it clarifies that integrative STEM education operates along an educational continuum and at all natural intersections of learning. It's mutually inclusive rather than exclusive. Specifically, it does not apply solely to the STEM subjects, but is applicable in both formal and non-formal educational settings and appropriate at any academic level. And finally, when using the acronym for Integrative STEM Education, I-STEM-ED, the I is capitalized so as to convey the equal significance of integrating alongside the STEM elements. The I is physically connected to those elements with a hyphen, and education always follows the elements to ensure that STEM is viewed in the educational context. Integration as a pedagogical strategy to promote student understanding is powerfully conveyed in the STLs through statements such as, students are expected to synthesize and apply information from all subjects, as well as within the study of technology. In this way, they learn to make connections among different fields of study and begin to understand how all knowledge is interconnected. Achieving student understanding, not merely content and procedural knowledge, is the fundamental learning outcome for integrative STEM education. True understanding is achieved by engaging students in technological and engineering design-based learning, where the explicit instructional goal is intent on having students designed to understand and working toward development of a viable engineering solution that meets human needs.